Let's get going, okay? As I said, we're going to do graphs, so we're going to do a quick recap of how we find coordinates. So I'm going to need you guys to help me with finding the coordinates of A, B, C, D, and E. Let's get started with A, which is right over there. Okay, point A. Remember, if you're going to send coordinates, send them correctly in the formats that I have taught you. So how do we write coordinates again? Beautiful, Senyani. We're off to a great start. 3 and 4. 3, 4. So for those of you who said you were new to this, okay, remember we open our brackets. You write the x coordinate first. You put your semicolon, the y coordinate, and you close your brackets. Okay, so get coordinates B, point B. What are my coordinates for point B? It's right over there. Let's see, -3, 1, 2, 3, and 1, 2. That is correct. -3 and 2. For some of you, this might be too small. Maybe that's better. Let's see, point C. My coordinates for point C, -2, -4. Let's see, 1, 2. 1, 2, 3, and 4. That is correct. -2, -4. Point D, 6 and -3. Okay, we are at 6. 1, 2, 3. That is correct. 6, -3. And the last one, E, which hasn't moved up, down, and it hasn't moved left or right. So then my coordinates for both X and Y will be... You need to write them properly as coordinates, guys. Still in the form XY, like so. Nice. It's 0, 0. It's not just a 0. Otherwise known as the origin. Oh, my handwriting went south fast there. Speaking of handwriting, we have to draw graphs today. And they may not be the best graphs I've ever drawn, but you guys will be okay. You'll be fine. You'll be fine. Okay, let's get going. Let's draw the graph of y equals 5 minus x for values of x from -3 to 3. So I'm going to draw this graph with you. Then I'm going to ask you a few questions to see if you know some terminology that has to do with graphs. All right, let's get going. Number 1, input number 1 is -3. So then y is equal to 5 minus -3. What happens with these two negatives in between here? They become a positive. So then it's 5 plus 3. So my output is 8. Good. Next one, y is equal to 5 minus -2. Once again, those two negatives become a positive, so it's 5 plus 2, and this will give us a 7. Maybe I should fill this in on my table. 8, 7. Next one, y is equal to 5 minus -1, which is 5 plus 1, which is 6. What is happening with my outputs here? Do we realize anything? What is happening with our outputs? Decrease by 1. So we don't have to go through all of this. What will be my output for 0? 5. And my output for 1? 4. Output for 2? 3. And output for 3? It's 2. Okay. Now, there is a way we could have found this out without going through all of this, but we will do those properly when we are doing graphs, not this one, all the graphs, functions. Are they called functions? No, there's another special name I'm thinking of, but now I forgot it. Okay, now let's plot this graph. Okay, now my Cartesian plane does not have a bottom part. Does anybody know why? Look at my numbers and tell me why I didn't bother to write the bottom part of my y-axis. What do you guys think? Why are we only using the top? There we go. There are no negative y values. So when you draw a graph and you have now filled in your table, that's why I say don't draw your axes before you fill in the table. First, fill in your table. See where your graph starts and ends. Okay, that's also to avoid a graph that does not fit on paper. You can't draw a graph like this if your inputs go up to 10 because then they won't fit. So you first fill in your graph, your table. I'm contradicting myself. You first fill in your table and then you look. Where do my x values start and end? And then you draw your x-axis according to that. And where do my y values start and end? And you draw your y-axis according to that. But obviously still has to start at a 0. So let me plot this quickly. I'm going to zoom out so that I can see my points and I don't keep scrolling up. There we go. Okay, -3 is all the way there. Goes with 8, which is there. My -2 is going to go with 7. -1 with 6. 5, 4, 3, and 2. And because I'm not the most artistically gifted person on earth, I am going to use a line. Oh, there we go. Make it thinner to see. There we go. All right, now let's ask a few questions here. Question 1, why does my line have arrows? Why did I not just use an ordinary line here? There we go. Okay, it has arrows because the graph will continue. Okay, so my graph continues. Second question, what happens if you draw this line in, but there is one point that's all the way over there? What do you think would happen then? You've done all your calculations, you've plotted your points, you draw a line, and there's a point right over there. What is the problem? Alice says it becomes a shape. Charlie says 2 lines. Mutebang is correct. Guys, if you are doing a graph like so, but there's a point that does not fall on the line, the chances are is it's incorrect. So the point of this is check your answers. All right. Next question. Is this an increasing or a decreasing graph? I only have one response. All right. There's more. Why do you guys say it's a decreasing graph? Which values do we look at when we decide whether it's an increasing or a decreasing graph? Nice, Alice. We look at the y values. So you say y values are decreasing. So this is a decreasing graph. Okay. What about the gradient? You can look at the gradients as well. We just haven't done it yet, Bernard. But Bernard is right. What about my formula tells me that this would have been a decreasing graph? We didn't even have to draw the graph to know this. My formula is y equals 5 minus x. What about this tells me this would be a decreasing graph without even drawing it? It's negative. Okay, if the number in front of your x, your gradient or your coefficient or whatever you want to call it is negative, then it is a decreasing graph. And if that number is positive, then what type of graph do we have? If that number is positive, we have an increasing graph. That is correct. And finally, is this a linear or non-linear graph? This is a linear graph. What does linear mean? What does linear mean? It is a straight line graph. Straight line. Now, once again, what about my formula would have told me that this is a straight line graph? We didn't have to draw it. You could have just looked at the formula and said, this is a straight line graph. What about this formula? Y is equal to 5 minus x. Marlene says the x values, before you even get there, just based on the formula, this one. This guy over here. What would have told you about that it's a linear graph? What about that? Would have told you. Decreasing by 1. Kirini, remember I said we don't even look at this, right? Don't look at the table at all. My formula would have told me something. For instance, if I just write a random formula here, y equals 2x plus 1. Is that going to be a straight line graph or a linear graph? Or is that going to be a non-linear graph? What are we saying? I'm not drawing anything. Non-linear, Alice is not sure. Guys, this is a linear graph because x has an exponent of 1. Now, as soon as x starts having x squared or x cubed, we have a problem. These two graphs will be non-linear. Do we get it? So on my x value here, x has a coefficient of, exponent of 1. We don't write it, but we know it's a 1. So as soon as x has an exponent of 1, then it is a linear graph. Now give me a thumbs up, thumbs down on all of the information we just said now, which was a lot of information. Do you understand all of these concepts? Yes, Pamandla.
Oh, sorry, ma'am. I meant to click thumbs up.
Oh, okay. No problem. No problem at all. Seems like we all understand. So without even drawing these graphs, you would be able to tell. Andile, where did I lose you? You can unmute and tell me.
Hello, ma'am.
Hello.
How are you, ma'am?
I'm good, and you?
I'm good. Ma'am, I don't get it, ma'am. Since you said 2 and 3, ma'am, is there more values that can be non-linear?
As soon as your exponent is not 1, then it isn't a linear graph.
Oh, thank you, ma'am.
So if your exponent is not 1, immediately you know this is not a linear graph. The only time it's linear is when the exponent is 1. Okay,
Okay, thank you, ma'am.
you're welcome. And guys, don't get confused by the numbers that come after this. Don't get confused by +1. +1 just means take your straight line graph and move it 1 unit up, but it is still a straight line graph. Okay, it's still a straight line graph. You're just moving it up or down. Okay, let's continue. Now, based on everything I've said, we have a graph here. They're asking us to draw a graph, y equals x squared. Is this linear or non-linear? Based on everything we just discussed now, do you guys think this graph will be a linear graph or a non-linear graph? It is not linear, okay? Because x has an exponent of 2. It is not exponential, it is quadratic. Exponential means the x is in the exponent. That is an exponential graph. I'm glad you guys know about the variety of graphs, though. Means you know stuff. Now let's get our points here. Y is equal to -5 squared. What's -5 all squared? Remember the negatives in the brackets as well. So -5 squared is 25. Okay, next one, y is equal to -4 squared. That is 16. y is equal to -3 squared. That is 9. Let me write the 69. Y is equal to -2 squared. That is 4. I'm going to continue on this side. Y is equal to -1 squared. That is 1. Y is equal to 0 squared. You guys are going very fast. That is 0. Y is equal to 1 squared. 1. Y is equal to 2 squared. 4. What's happening here? Does anybody notice something that's happening? 4, 1, 0, 1, 4. What do we notice about my inputs there? My outputs. English is tapping out here. All numbers are positive, but also what? What happened after 0? What happened after 0? No. It's the same pattern, Londeka. So what do we think is next? They are mirroring, beautiful, Rolivua. They are a mirror of one another. So then what's after 4? 9. And then after 9, 16. And then after 16, 25. So these are mirrors of one another. So after 0, they started mirroring one another. We started with 1, then 4, and then 9, 16, 25. Okay, now let's see what this graph would look like. What do you guys think this graph would look like? As I plot my points, you guys discuss in the chat what you guys think this graph would look like. Let's hear. Any ideas? 2 is at 4. 2 is there. 3 is at 6, which is there. 4 is at 9, which is there. There. 4 is at 16. I just lost it. I just lost my life. Okay, let's see. 1, 1, 2, 4, 3 is at 9, guys. 3 is at 9. 1, 2, 3 is at 9, which is over there. There we go. 4, that looks more realistic, like what I'm supposed to draw. 4 is up there, and 5 is at 25. I see you guys saying it's a V. So if you're saying it's a V, that means if I put 2 straight lines over here, they must cross all the points. Do they cross all the points? No. So it is more of a U. It's more of a U. Okay, it's definitely not a V, because if I put 2 lines that were straight like this, they would not cross all of my points. Now, this is what we spoke about, guys, right? My drawing skills are not very fabulous, okay? So you guys are just gonna have to use your imagination here, because when I try to draw this graph, why is it so thick? Oh, it's the cookie. Oh. Okay, let's see. Whew. Just imagine it's crossing all the points. I promise you I'm better at this on paper. I just can't do it on the computer. Who is judging me? Oh, that's such a beautiful one, but it's not crossing all the points. Oh, that was so beautiful, guys. It's fine. You don't want to give me my credit. It's okay. Let's see. Let's see. Let's see. There we go. Woo! Wait until you guys have to draw them. And wait until you have to draw trig graphs, trigonometry graphs. Then we'll start talking. Okay. We can compete on paper. One day I'm going to show you my camera and show you how I draw it on paper. But it's fine. The point is it's more of a you. Thanks, Londeka. Thank you. Everyone else is just being jealous. And Andile, thank you. And Marlene, thank you. Okay, so this would be a quadratic graph. But the point of this was to show you that as soon as my exponent is not 0, then my graph is not straight. The x cubed graph is more of a it has 3 sides. It's more like that. There we go. That would be the x cubed graph. Okay. Let's move on. Okay, that's just another straight line. There we go. Now, we're going to find the equation of this graph. Okay. We're going to find the equation of this graph. And obviously, that means we have to start with finding the points. Now, luckily, we're not going to write all the points down, just the ones that are included in this table at the bottom here. So let's start. For an input of -2, okay, I already told you it's an input. Are we going to look for it on the x or the y axis? Where are we going to look for this -2? On the x-axis. So then what is my corresponding y value? It's over here. So then my y value is -3. Nice, it's this point there. So it's -2 that goes with -3. Great. Next one, for in -1, an input of -1, what is my corresponding y value? It is also -1. The next one, if my x value is 0, where are we looking? Nice, we're looking on the y-axis. All right, so we look on the y-axis. So then it's this point over here. It's the only one that is crossing the y-axis. So this would be 0 and 1. It even told you in brackets, guys. For 1, my input value of 1, which is over here, what would my output value be? It is 1, 2, 3. Okay, and for 2, the last one, it is 5. It is 5. Okay. Sorry, I just need to do this very quick. There we go. So let's look at my multiplier. How am I getting from -3 to -1 to 1 to 3 to 5? We are adding 2 plus 2 plus 2. So then 2 becomes my, what does 2 become? What do we call it? It's my multiplier. All right, so then I start off 2 times -2. What's 2 times -2? -4, but my desired output is -3, so I have to plus 1. That'll give me -3. And we're going to try it again with one more. 2 times 2. Let's go with that one. 2 times 2. That's going to give me 4. And if I add 1, I get 5. Is that what I'm looking for? Five is what I'm looking for. Therefore, my equation, as Singyani has said twice now, is 2x plus 1. Beautiful, Singyani. You got it very quickly. 2x plus 1. All right. Now we're drawing a graph again. This time it's y is equal to 3x minus 1. Before we even go anywhere, firstly, is this a linear graph? Y is equal to 3x minus 1. Will this be a straight line graph? Alice says yes. What does everybody else say? Tali says yes with a question mark. I don't know. Yes, it is a linear graph. Why is it linear? Give me my reason. You haven't drawn it yet, so your reason can't be. It's straight. Not no exponent. The exponent is 1. Guys, be careful. The exponent is 1. All right. Next thing, is this an increasing or a decreasing graph? Increasing or decreasing? Alice is the only one who answered me. Okay, I see more responses. We're getting confused. Remember, we're looking at this number. Currently, this number is positive. So a positive coefficient or gradient means it is a increasing graph. This is an increasing graph. Don't look at the -1. Increasing, because I'm going to say coefficient or gradient is positive. Okay. So we know it's going to be a straight line that is increasing. Now let's get going. So it's y is equal to 3x minus 1. Okay. 3x minus 1. Now let's get going. First one, y is equal to 3 times negative 2 minus 1. What's 3 times negative 2? 3 times negative 2. We're not answering my question. There we go. This is negative 6 minus 1, which will give me negative 7. Guys, be very careful of skipping steps, because if you make a mistake, you will lose all your marks. Okay? Next one, y is equal to 3 times negative 1 minus 1. What's 3 times negative 1? Nice, Pamantla, negative 3. And if I subtract 1, that is negative 4. Next one, y is equal to 3 times 0, which is a 0 minus 1 is negative 1. Next, y is equal to 3 times 1 minus 1. What's 3 times 1? That is 3 minus 1 is 2. Nice, guys. You guys are on fire. Last one, y is equal to 3 times 2 minus 1. What's 3 times 2? That is indeed 6. And if I subtract 1, that is a 5. So let me fill this in. Negative 7. Negative 4. Negative 1. 2 and 5. Okay. All right. Let's get plotting. Okay. First one for negative. Okay. First of all, what do one of these lines represent? What are we going up in? You do know you're allowed to make your number line so that you go up in different numbers, right? As in, you are allowed to say 2, 4, 6, 8, as long as you're going up in the same interval. So these are going up by 5, but I'm asking, what do these individual lines, what are they going up in? Are we counting in 1s or 2s? Or in 1, okay? So if that is negative 5, that means negative 2 is over here. Do you guys see the point? Negative 2 is over here, and negative 2 goes with negative 7. Negative 1 goes with negative 4. 0, negative 1. 1 with 2. And 2 with 5. And I draw in my line. And once again, I'm using the arrowed one because this line keeps going indefinitely, as in forever. If I can just fix it. How are we going to make sure we draw a proper straight line in a test or in our books? With a ruler, please. Do not freehand it. You saw what happened when I tried to freehand one. Didn't go well for me, ne? So you must use your ruler always. Not always, only if it's a linear graph. No, do not freehand it, please. The teacher will have a heart attack. Okay, and as we predicted, it is indeed linear and it is increasing. Because if you look here, the y values are going up. Okay, we have another one here. Once again, increasing or decreasing? Increasing or decreasing graph? This is decreasing, Kat. I couldn't trick you this time. Why is it decreasing? We're not saying anything. I'm just seeing a bunch of negatives. What is negative, guys? Nice, Klali. Coefficient is negative. And I already told you that it is a linear graph by asking if it's decreasing or increasing. So y is equal to negative x minus 3. Let's get going. Y is equal to negative 2 minus 3. Now, before we even continue, I need to highlight that my first negative here is from the formula, and my second one is from the value itself. So then it's going to give us two negatives, which will make my 2. What is my final sign for 2? Positive. You don't have to write this positive. I'm just writing it so you can see what happened here. So now it's positive 2 minus 3, which means my output will be negative 1. For my second one, y is equal to negative 1 minus 3. Negative 1 is positive 1 minus 3. So my output is negative 2. My next one, y is equal to negative 0 minus 3. Can 0 even be negative or positive? It can't, it's neither, right? So this is just the same as saying 0 minus 3, which is negative 3. And we have y is equal to negative 1 minus 3, which is negative 4. And finally, y is equal to negative 2 minus 3. That will give us negative 5. So this is negative 1, negative 2, negative 3, negative 4, negative 5. What else does my coefficient or gradient tell me? Whoever brought up gradient, you should be able to get this. If I wanted to fill in my table without doing all of these calculations, how else could we have done this? Just using the gradient, filling in my table. Decreasing by negative 1, because if it's just the negative there, that means it is negative 1. Okay. So then you could have found the first point and then just went and decreased it by negative 1. You did not have to go through all of that. Okay. Wonderful. Now, let's get drawing. You are smart, Pamandla. You guys, whew, you guys. Okay. So once again, all of my output values are negative. So would we have had to draw this top part of my y-axis? Was that necessary? No, it wasn't. Okay, but this is just a Cartesian plane that I found with both sides. So, but if you were drawing this as to not waste paper, you did not have to draw the top part of your Cartesian plane. So let's get going. Negative 2 goes with negative 1. That's over there. -1 with -2, 0 with -3, 1 with -4, and 2 with -5. And if I insert my line, we'll see that it is all a straight. Well, if I can draw a straight line, that would be fabulous. But it is a straight line. There we go. Also, you must also not use cookies. Okay. And delay, we stick to the curriculum. We do not do grade 11 maths. What is grade 11 maths, guys? Who told you it's grade 11 math? Oh, we have brain break. Who wants to take part in the brain break quickly? I can't believe we're here already. Hello, Tlali.
Hi, ma'am.
Would you rather eat with your belly button or drink with your ears?
Eat with my belly button.
Oh my goodness, Tlali. So you must just sit there and like open. No ways. That's too
Ma'am,
weird for me.
it's gonna block my ears. How am I gonna hear? And the wax. Imagine drinking.
Your belly button's also not clean, by the way, guys. I'm
It
just saying.
is. Ma'am, you
Oh,
clean it every day.
continue. Continue eating with your belly buttons, guys. You put lotion on it. You do. Oh, I can't. I can't even. I'm unable to think about it. Alice,
Hello, ma'am.
Alice, would you rather sound like a cow or a chicken when you laugh?
I'd have to go with a cow because chickens are annoying and I'm kind of scared of them.
So you'd rather go with the less annoying one.
Yes.
Wonderful. I see a lot of people. And let's say it's chicken. And so does Tlali. Oh my goodness. Okay, it seems like most of the people are with you here. Nelson, are you with me?
Hi, ma'am.
Hi, Nelson. Would you rather have tiny feet and huge hands or huge hands and tiny feet?
Uh, Huge hands and tiny feet.
Huge hands and tiny. Okay, I don't know. Why that one?
You see, ma'am, with the huge hand, I can still like play basketball and that stuff. And then with tiny feet, I can also play soccer. But then with huge hand, with tiny hands, it will be very hard to pick up a spoon or use a pen and that stuff.
That's true. That is true. I see where you're coming from. You thought about this one. I like it, guys. Nelson is focused. A focused person. Okay? Nobody else wants to do the brain break. Guys, I still have, I think, 2 more. No more volunteers? Ooh, Senyani, hello.
Hello, ma'am.
Would you rather shave all of your hair, as in all of it, eyebrows and eyelashes,
Yeah.
or lose all of your teeth?
I'd rather shave all of my hair. No, ma'am, I can't lose my teeth. Like, it just feels wrong.
What would you look like without eyebrows? Have you ever thought about that?
But you can draw eyebrows. You can't draw teeth.
As long as you don't draw them like this, ne? Oh my goodness. Wow, guys, no. When you look strange without eyebrows. Honestly, you look very and eyelashes, guys. You look very strange. I can't even. Your name says group 2. I don't know who it is. Please unmute. There we go.
Hi, ma'am. It's Maya.
Hi. Would you rather always think about this, always drink from a huge bucket or from a baby bottle?
I'd say baby bottle.
Have you ever been thirsty, man?
Ma'am, but the thing is, with the baby bottle, you can Refill it with a huge bucket. What if you can't finish all that water? Now you're wasting water.
No, you don't have to waste it. You just put enough. Oh, see, Alice has a plan. Alice is going to use a straw. Guys, have you
No,
ever played
ma'am.
sports and you are thirsty and all you can drink is like little bit, guys, you're going to die of dehydration. I'm just
We
saying.
wouldn't. Ma'am, I'm telling you, a baby bottle's better than a huge cup. A huge
No.
bucket.
No, I'd use a bucket, guys. I'm sorry.
Mm-mm.
I will use a bucket any day. I can't do it, guys. Baby butts, I'm gonna die from thirst. Oh my goodness. Yes, Alice. So you don't have to walk around with the bucket, but like imagine you're at a restaurant and you're like, I'm gonna have a Coke, and they bring it in like a bucket.
No, ma'am. Mm-mm.
Okay, guys, I get it. I get it. Okay, guys, let's continue. Where's my, oh, there we go. Okay. All right. Now find the equations of these three graphs. Oof. Okay, so we have three graphs over here. And I want the equation of all of them. Okay, how do we find equations of graphs? Equations of graphs. How did we do that? Excuse me. We need coordinates. Thank you, Alice. We need at least how many coordinates? Alice says 2. Okay, what does everyone else say? How many coordinates would you guys say we would need to find the equation of a graph? At least 3. That is smart, okay? The reason is, Alice, you need to check if your difference is the same everywhere. So if you have 2 points, you can't exactly check. Do you see what I mean? If it says the difference is 2, then the difference is 2. But you don't know if that corresponds with the next difference. Okay, so I'm going to start with the graph that I'm numbering A, which is the blue graph. Okay, so let's find some coordinates of the blue graph. I'm going to draw a dot over here and over here and over there. What are my 3 coordinates? There, there, there. Okay, let's go. This is A, this is B, this is C. Coordinates of A. It is 2, 6. Thank you. Coordinates of B. 1 and 5. And oh, we can't see. That's why. There. Is that better? There we go. I'm getting answers, so I feel like it's better. Then C, the coordinates. You're welcome, Marlene. Is 0, 4. Okay, if I were to draw these in a table, I would have my X and my Y. And then as I said, your X's has to be increasing. Let's not make the same mistake we made almost made. Okay, so X has to be 0, 1, 2, which means my Y's are 4, 5, and 6. Okay. 4 in C. It is on the axis. Do you see that? There. 1, 2, 3, and 4. There. I hope I clarified. Okay, so what is my multiplier here? It is 1. Thank you. You're welcome, Andile. So if I say 1 times 1, that's going to give me 1. So what do I have to add? I have to add 4, and that's going to give me 5, which is what I want. Then you check 1 times 2, which is 2. And if I add 4, I get 6. Is that what I want? Yes, so then my equation is y is equal to x plus 4. Nice. Okay, we're done with graph number A. Let's move to graph number B, which is going to be a little bit more interesting. Okay, so the coordinates we can definitely get are these ones that are over here. Okay, but we're skipping numbers. Do we see that? It's 0 and oh no, but the x's are corresponding. Never mind. The x's are corresponding, so we are not skipping numbers. Never mind. I thought it was a different type of graph. So let us, maybe I should name them. This was A, B, and C. This is going to be D, E, and F. Let us get going, okay? Point D. Point D. I see Singyan is already giving me point F. Point D is -4 with 4. Point E. I'm going to write F here because Singyan already gave me point F. And that was -2 and 0. This one is -3, 2. Nice, guys. All right. Once again, x, y. My x has to be increasing. So I started -4, -3, -2, which means my outputs are 4, 2, and 0. What is happening here with my outputs? We are minusing 2. Okay. So then -2 is my multiplier. So I'm going to go ahead and say -2 times -4. What's -2 times -4? It's +8. But we want an output of 4. So what am I going to do? I'm going to subtract 4 and I'm going to get 4. Let's try it with something else. -2 times -2. What's -2 times -2? That is +4. And if I minus 4, I'm going to get a 0. So then what is my equation of this graph? Y is equal to -2x minus 4. Now, let's look at the third graph. Okay. If I choose this point over here, what is my y value? Actually, just tell me the coordinates of this point over here that I've just chosen now. -4 and 6. And what about this one over here? -7 and 6. And what about this one over here? Seven and 6. What's going on here, guys? And this one over here is 4 and 6. What do we realize about this graph? What do we realize about this graph? It's not mirroring. Not quite. That's not what I'm looking for. Nice, Andile. Does my y value change? No. So this graph is literally y is equal to 6. Because no matter where you go on the x-axis, y will always be 6. Okay. Do we understand that? Let's have a thumbs up, thumbs down. No matter where I go on this graph, y will be 6. So the graph equation is y is equal to 6. I have very few thumbs up for the number of people that are in here. Wonderful, that's much better. Much, much better. Okay. Let's find the equation of the last graph and then we can call it a day. Okay, let's find the equation of this graph by using how many? Okay, let's just use 3 points. This one, and this one. First one, point A. Coordinates for point A. My coordinates for point A. Nice. 0, 2. Point B. 1, 5. And point C. Point C is 2, 7. 0, 1, 2. This is not 2. This is not 2. The first point, guys, look carefully. It's 0 and 2's over here. It is. It's 3. 0 and 3. Oh, we almost got caught there, guys. So then my input for the first one, what is my x value for my first coordinate? 0 for the second one. 1 and the last one. 2. Are they in the correct order? Before I write my outputs? Yes, they are because they're increasing. Okay. Now let's write my output. Output 1, 3, numbers 2 is 5, and the last one is 7. What is happening here with my outputs? We are adding 2. Okay, so 2 is my multiplier. So I'm going to say 2 times 1 is 2. What do I still need to do to get to where I need? I need to add 3, and that's going to give me 5. Let's check it with the other one. 2 times 2, that's going to give me 4, and if I add 3, that is 7. Therefore, my equation is y is equal to 2x plus 3. Nice, guys. Off to do the quiz you go. Good night.